the adjacent side is along the x-axis and going to the left, we basically have a negative adjacent over a positive hypotenuse. We have a negative adjacent over a positive hypotenuse. What's a negative divided by a positive? Negative. So the cosine of 2 pi over 3, 120 degrees, is going to be the negative of the cosine of 60 degrees. So it's going to be negative 1/2. It's negative because this adjacent side is along the x-axis in the negative direction. So when you're creating angles on the unit circle and making these triangles, you use the reference angle the same way that you use those angle measurements, but you keep track of whether x or y is positive. All right? The tangent, yes, will be opposite over negative adjacent, actually. Okay? So is that going to be positive or negative?
Negative.
Negative. Positive divided by a negative is negative. What's the tangent of 60 degrees? I'm using the reference angle again.
3.
Square root of 3. So this is negative root 3. Okay? This next part goes a little bit faster. Not opposite.
Reciprocal.
Reciprocal. You flip the fraction. Our 3 favorite words will all come into play this lesson. So the cosecant of theta, cosecant is the reciprocal of which trig function? Sine. I'm writing them in order for a reason. So this will be 2 over root 3. If you rationalize the denominator, it'll be 2 root 3 over 3. I'll leave that step to you guys. The secant of theta, what's the reciprocal of negative 1/2?
2 over 1.
Negative 2 over 1, or just negative 2. And what is the reciprocal of the tangent, which we call the cotangent? Bless you. I've got a negative root 3.
1 over negative root 3.
Yeah, negative root 1 over 3. Negative 1 over root 3 or negative root 3 over 3. Let me move the podium for Maya before she asks me to, because she's writing all this down diligently and paying close attention. Okay? This is it. So, what you do is, you figure out where your radius takes you when you're asked to find an angle. Let me start the sentence over again. When you're dealing with angles greater than 90 degrees, you draw the radius on a unit circle. You figure out whether x or y are positive or negative. If you're without a calculator, which I believe most homework tonight is meant to be done without a calculator, then I promise you the reference angle will always be one of these. You'll always get a reference angle of 0, 30, 45, 60, or 90. Follow my fingers and look while I do this. I want you to start picturing these as 0, 30, 45, 60, and 90. Pi over 6, pi over 4, pi over 3, pi over 2. Okay? Pardon? 0 is pretty easy. I think that transfers well. You're right. If anyone gets that one wrong, I will cry. So the reference angle is going to be one of these if you don't have a calculator with you. Okay? But you got to find the right reference angle. So now let me do another example, and I'm going to try to erase everything except for Elena's circle, because I know I can't do it as well.
Is
60 was the reference angle, yes, for 120 degrees. Pardon?
How do we get that?
We went to 120, and we asked ourselves how much further would we have to go to get to the x-axis.
Okay, got it.
It's always to the x-axis.
So to the nearest x-axis.
Yes. Does everyone have this? So can I erase this?
Sure, go ahead.
This part, at least starting up here. Okay. Okay. Next example. 315 degrees, or what is that in radians? Is 315 divisible by 30, 45, or 60? 45, yes. It's not obviously divisible by 30 or 60. How many times do you think 45 goes into 315? 7, yeah. 6. One way to do it is 2 45 degrees gets you to 90. 2 more gets you to 180. 2 more 45 degree angle gets you to 270. 1 more. So this would be 7 times pi over 4, or 7 pi over 4. 300. Okay.
45 times 7.
If we're doing this without a, if we're doing, 7 times 45. So if you're doing it without a calculator, the angle you get is going to be a multiple of 30, 45, or 60. Because we promise you those are the only ones we'll give you without a calculator. Yes?
It's you do it 7 times, but pi 4 is automatically 40, and then you're just multiplying that by 7, so you go around it. You go around the circle 45 times. Or you go around the circle 7 times, 45 degrees. Is that right?
You go 45 degrees 7 times. The last way you said it was right. Yeah.
Okay.
So you go 45, 90, 135, 180, 225, 270, 315.
Okay.
Good solve. Good way to picture it. I'm a big fan of visual on the circle. Okay, so I go down here to 315 degrees. And now what's my...
45.
Saul, before I can even ask it. Saul's right. It's going to be a 45 degree reference angle. Now down here, is my x positive or negative? Positive. Yeah. So it's, and will y be positive or negative in this quadrant? Negative. So I have a negative y, a positive x and a negative y down here. Okay, my reference angle is 45 degrees. So I use the reference angle to get my values. So all my values will come out of this pi over 4 row of my table. But I've got to figure out if they're positive or negative now. So the sine of 7 pi over 4, or 315 degrees, is the same absolute value as the sine of 45 degrees, which is? That's the radian, but it's root 2 over 2 is the value. Now sine is the same as y. Is that positive or negative in quadrant 4? Negative. So we have negative root 2 over 2 for the sine, because the opposite down here is negative. Hypotenuse is always positive. The cosine of 7 pi over 4 has the same absolute value as the cosine of 45. What's that equal to? Root 2 over 2. Is it positive or negative? Positive, because x is positive when you're down here in quadrant 4. The tangent of 7 pi over 4. Okay, tangent I said is sine over cosine. What's the tangent of 45 degrees? 1. Is this going to be positive or negative? Negative, because it'll be a negative divided by a positive. Here's another hint. On a line through the origin, the tangent is the